So, Saeed, I warmly welcome you to Researcher's Desk. You've jumped in at the last minute to present for us your newly published work. Saeed, you're at the Blaine Center Department and the Department of Physical Geography, and you're going to talk with us about climate and human impacts from Swedish lakes. Saeed, we warmly welcome you. I'm going to turn off my own camera and my microphone, but I'm here in the background. And if anything feels strange, just give a shout and I'll jump in and help you out. And if anything's going wrong, I'll suddenly appear. The floor, Saeed, is yours. A warm welcome to Researcher's Desk.
Yes, thank you so much, Alasdair, for inviting me to this seminar series. Thank you, Researcher's Desk, and thank you everyone who has joined today. Yes, today I'm going to talk about climate and human impacts on Swedish lakes, and I'm going to repeat this title several times during my presentation. So I have put a QR code on all slides with a little dinosaur in it. So if you just scan that, you can access to the article if you needed to know more details about this study. So I'm Saeid Aminjafari. I did my PhD at Stockholm University, Department of Physical Geography. I defended my thesis 5 months ago, and this study is one of the papers that I have in my doctoral thesis. So let's start first answer this question. So why lakes? Here I show a beautiful picture of Brunnsviken Lake, just on the other side of the highway from us. And the answer to this question, that why lakes, is not that hard, because I mean, we all know that lakes globally are important sources of fresh water, water for agriculture. They have great biodiversity. They can serve as flood control storages. There are a lot of recreational activities in the summer, for sure. And a lot of people do fishing. They go fishing there. So they are important. So this we know for sure. And in particular, in Sweden, with the large amount of lakes, I think the importance is even more highlighted within this context. So we need to monitor the status of the lakes, in particular their water levels. The reason is that any changes in the water level of the lakes, long-term changes I'm talking about, it can change the services that lakes provides. So we need to know what's going on, how's the situation of the lake, and then let policymakers know, and that they can sort of do preventive actions or protection policies they can apply. And also, if there are changes in other hydroclimatic variables, such as precipitation, temperature, something that we know as climate change. So if there is a signal of that on the lake, we can see that in lake water levels. Also, our impact, because we use lakes for different purposes, hydropower, agriculture. So if we are affecting lakes by looking at the changes in lake water levels, we can understand those. And also these lake water levels, the observations can be used for calibration and validation of hydrologic modeling. But there are challenges. So measuring lake water levels is not as easy as we think. There are global data sets of lake water levels. But because of the nature of these global data sets, they don't have a proper temporal resolution because there is no regionally focused studies. And when it comes to in situ measurements, There are other problems. The installation and maintenance is not easy, especially when the lake is located in a remote area in the mountains, especially in Sweden when it's in the winter. It's not easy to keep those networks working. It's costly, it's labor demanding. So I always use this example in Sweden and this funny cartoon to show the seriousness of the challenge, that among 100,000 lakes in Sweden, less than 1% are being monitored. And with that less than 1%, there is not a comprehensive study on them. So we are just collecting a very small number, collecting the data from a very small number of the lakes, and we basically don't do much with them. To address this challenge, so together with in-situ data that I've received from SMHI, I have also used satellite data that they give us information of lake water levels. So the importance of satellite data, I don't want to get into details of the method, but the importance of the satellite data is that they have proper temporal, spatial resolutions, and they have a broad coverage. They're so cheap to get them, so easy to process them, and with the advances in technology and cloud computing platforms, it's so easy, so fast, so efficient, so reliable. They have day and night measurements in all weather conditions. So I combine this data, satellite data, with in-situ data to address hydrological questions related to water level. Okay, here I am showing the map of the world. So in this study, I wanted to see if there are changes in lake water levels here in Sweden in 144 lakes. And if there are changes, what are the factors that they're causing those changes? So in this map here, I show those lakes that I have data from satellites with dark blue circles, and also in situ measurements, which are those circles in light blue. One might ask why 144 lakes? The reason is that the data that we got or processed for these lakes had a reasonable temporal resolution and good accuracy. But before I move on to the results, I should tell you this story that usually when researchers want to develop an idea, they would think if the outcome would be published, rather than thinking if the idea is important and useful. So when we first wanted to start this study, I thought with 100,000 lakes in Sweden, there should be a study answering how these lakes are doing. But it came as a surprise to me that no, I did some research. There was not much about like the changes in lake water levels. So first, it is important to add that we did this study in two periods. First, the last 10 years, and also the last 30 days. So 1 decade and 3 decades. But the overall results of both periods were very similar. So I show the results for the last decade that we had more data. And if you want to know about the longer period, you can go to the article and read there. So I want to first answer the second question, which was about what are the drivers of the changes in lake water levels. So I assure you that there are trends in water levels, but I'll show you this later. So let's begin with human impacts. So in order to understand what is the human impact on the lakes, we divided the collections of the lakes into 4 categories that I show here. So We have 95 lakes that are not regulated, shown with letter N, non-regulated, and the blue bar. So non-regulated, I mean that the water in the lake and the water that flows into the lake is not being systematically used for different purposes, for hydropowers, channels, or irrigation. And then we have 10 lakes that there are regulatory structures, such as dams, on the upstream of the lakes before water flows into the lake. And then we have this I show with letter U, means upstream regulation. And then we have lakes that they are directly regulated. So there is one regulatory structure directly in the proximity of the lake that we show with letter R, with the pink bar. And then lastly, we have those lakes that they are highly directly and indirectly regulated upstream and on the lake. So in order to understand how human is impacting the water levels in these lakes, I want to show you the water level trends of lake collections in each category. So in this figure, on the vertical axis on the left, I'm showing the water level trend. The unit is centimeter per year during the last 10 years. And each bar is related to this value for each category of the lake. So even without looking at the numbers or doing any statistical analysis, we could visually observe that the 10-year trends in water levels of the collection of non-regulated lakes look different from those that they have any types of regulatory structures. Therefore, we suspect using the water of the lakes during the last 10 years, directly or indirectly, has changed the water stored in these lakes. In order to talk with numbers and trust the statistical analysis, here we have a table that shows the difference between water level variability of the lakes within different lake categories. So the numbers, to understand this table, let's look at the second row, which starts with the letter N. So if we look at the intersection of letter N with letter U, R, and U plus R, we can see small numbers. So small numbers in this table means that water level variability in non-regulated lakes is different from those that are regulated in any form. And interestingly, looking at the third row, which starts with letter U, meaning that they have upstream regulation, and looking at the intersection with letter R and U plus R, we see large numbers, meaning that regardless of the regulatory type, the water level in regulated lakes are showing similar patterns. Let's move on to the impact, the sort of the combined impact of humans and climate change. So with another complicated matrix, this is a correlation matrix, I want to show if changes in other climatic variables, such as precipitation and temperature, influencing lake water levels. To make this matrix simple, let's focus first on the columns. So I show with the red ellipse here. So these parameters are related to changes in water levels. We don't need to remember their name and abbreviations, but they are water level variabilities and water level trends, overall and seasonal trends. And if we look at the on the rows with the red rectangular, we can see changes in precipitation and temperature. So let's look at this big red rectangular box. So the larger the value is closer to 1 or -1 means that there is a higher correlation, either in the same direction or different directions. So we can see that because these numbers are in color, so there is a correlation, but the values are very small. So the correlation exists between climatic variables and changes in lake water levels, but it doesn't have a large number. So this matrix is for non-regulated lakes. So when we look at the same matrix for the regulated lakes in the same box, we can see that these numbers are a bit larger. So, however, since the value of correlation are not large, can we say that that climate change is not impacting lake water levels like it is impacting other hydrologic variables? The thing that we know for sure is that when we do something to lake, when we regulate a lake, the impact of climate changes, even though it's not that big. But to answer that question, does a simple correlation tell us if there is no climate impact on the lakes? So here I get to the last and my favorite map of this study. So this map shows water level trends during the last 10 years. So the spectrum of blue means that there are increasing water levels or lakes getting wetter. And the red spectrum means that there are decreasing water levels. So the smaller circles are showing those lakes that they don't have a significant trend. And bigger circles are those with a significant trend. So when it comes to, so let's first look at the spatial variation of changing water levels. So there are 50% of all 144 lakes that we studied here, they had increasing water levels, that they were mostly located in the north of the country. And then we had 24% that they were located in the south and they had decreasing water levels. It is very interesting because when it comes to climate change, there is a global paradigm or global saying that in the face of climate change, wet gets wetter and dry gets drier. For instance, in dry regions of Middle East or Central Asia, we have the examples of Aral Sea or Lake Urmia that they are located in arid area and in the with climate change they are drying out. It's just very interesting that we can see this pattern in regionally focused areas. For instance, in Sweden, we can see that in northern Sweden, with generally more precipitation and snowfall, we can see that lake water levels are experiencing an increase. And in the south of the country, where there is like drier conditions, lakes are having or experiencing decreasing water levels. So even though we did not observe a high correlation value, we observed that spatially, lake water level change has different patterns in different areas that might be a signal of climate change. So to summarize, we were able to see spatial patterns of changing water levels that we suspect they are related to climate change, and we could see vividly that those lakes that they were impacted by humans, they had different water level change and variability. So this work should not stop here, because in this study, I used, when I performed this study, not all the satellite sensors were available. So we had only 144 lakes. With the new satellites, now we are able to monitor maybe more than 5,000 lakes. And with the even newer satellites, we can monitor almost all lakes in Sweden, plus rivers. This was all that I had for today. Thank you so much, everyone, for listening. So this was part of my PhD project that was funded by the Swedish National Space Agency.
Thank you so much, Saeid, for a fascinating presentation and a fascinating illustration of the complex interplay between human impact and climate impact, and trying to unravel what is the cause. You gave a really good impression of the challenges involved there, and your last figures showing the map are really quite chilling and worthy of discussion. So I thank you enormously for being with us at Researcher's Desk today.